I want to talk about security-related topic today, which is to restrict the permissions of the gardenlet in the garden cluster. I have two short disclaimers up front. So first of all, this topic is still work in progress, so it's not fully implemented. You cannot really use it today, but as part of the next weeks, we plan to finish it, and then you now already know what it is about and how it helps you. And the second one is that many things are actually inspired by what the Kubernetes community already has done as part of their efforts to shrink down the permissions of the kubelet. So if you are familiar with that, you will probably find a lot of similarities. Okay, then let's get started and talk about the problem statement first. So this here is the typical landscape picture that describes a gardener landscape. On the left side, there is the garden cluster with the gardener control plane, running the API server, the admission controller, controller manager, and so on. And then you usually have a bunch of seed clusters, which each have a dedicated gardenlet component installed. And obviously, each of these gardenlets has its own kubeconfig that it uses to communicate with the garden cluster, to watch shoots, to update their statuses, and so on. So now the problem is that these kubeconfigs, or more the users inside these kubeconfigs, are bound to the cluster admin cluster role. So all the gardenlets have permissions for everything in the garden cluster. And this obviously means, let's say we are in the situation that one of these seed clusters is compromised, and somehow an attacker gets access to this kubeconfig here in the case of Azure. Then obviously all the data related to the Azure seed is leaked in the garden cluster. But because it can access all the other resources as well, it also means that the entire landscape is kind of compromised now. So obviously this is a situation that is not desirable. There should be means to prevent this leaked kubeconfig in the first place, but if it happens, then what we at least should try to do is to restrict the damage that an attacker can do. And this is also what this talk today is about. So what we want to do is to restrict the access of the gardenlet to no longer be cluster admin, but rather only access those resources that it should or needs to access. And the first, or the typical solution in Kubernetes is RBAC, which for our use case is not really the right way. So I've depicted here a secret on the right side, which contains some AWS credentials. And now if somebody wants to read this secret, it's not really obvious in the first place whether it belongs to a shoot that also belongs to an AWS seed. So this resource relation is not obvious. So if you would want to use RBAC, it would mean that we would have to write a controller that is constantly and very frequently actually updating roles and role bindings. And this would result in significant write operations, and in the end to a lot of load on the API server and etcd. So the RBAC is not really what we need and what we can do here. Next step would be to think about implementing some custom logic in our Gardener API server, because this actually is a dedicated component where we can run more or less our own custom code. However, for the authorization, the concept not really allows to implement what we need here. So we can only delegate the decision back to the Kube API server. And for our use case, it's not really applicable what this extension concept allows. But there are in Kubernetes these custom authorization webhooks, and those would be then or this would be the concept that we can use. So this here is a screenshot of the documentation of the command line flags of the Kube API server from Kubernetes.io. And you see there's one flag called authorization mode, where some modes can be configured. Typically, the cluster has RBAC enabled and this node authorizer, but there's also this webhook option that you can set. And then further down, there are other options for the webhooks for caching decisions and for the configuration itself. So how would the Cube API server talk to the webhook? What is this address and so on? And also the webhook version of the payload the Cube API server sends. So in the end, this webhook is just an HTTP callback. So when a request is received by the Cube API server, let's say some user wants to read a shoot and this webhook is configured, then it would just ask or send a HTTP request to the webhook server, ask whether this is allowed or not. And depending on the answer, take the decision and respond to the user. In a little bit more detail, this here is the payload that would be sent by the Cube API server to the webhook server, the subject access review object. It contains the resource that wants to be accessed in this request. So in this case, it's pods. In this unicorn example API group, in this namespace, and for the get verb. And the user is Jane and has these two groups. And now you can implement arbitrary code and decide if this is allowed or not. So as webhook server, you basically have three options to answer here. First of all, is this request is allowed. Second one is the request is not allowed from my point of view, but I also don't want to explicitly deny it. So in this case, the Cube API server might also consult other authorization handlers. So this more or less means that you don't have an opinion. You cannot say, yes, it's allowed, but you don't really know. And the third option here is to explicitly deny the request, which would mean the Cube API server would not consult other authorization handlers. Okay, and this is basically now what we want to implement for our use case. So we would somehow need such an authorization webhook that we then connect to the garden cluster. And then for each request of a gardenlet, it would be consulted and asked, is this gardenlet allowed to read this particular shoot, for example, or this particular secret? And only if the secret or the shoot or whatever other resource is being accessed is related to the seed for which the gardenlet is responsible, only then it would be allowed. And with this solution, we would restrict the damage that an attacker can do if it compromises, for example, this gardenlet cube config. Okay, how is this implemented? Or how do we plan to implement it? We have here a picture of a resource dependency graph describing the resources of the Gardener API more or less, but also some of the Kubernetes resources that you see here in blue, namespaces, secrets, and config maps that are also used by Gardener when, for example, the shoot is reconciled or for other use cases. So we see here how all the resources that Gardener at some controller creates or maintains are related to each other. So what we want to build is some directed acyclic grave data structure, which we store in memory in this webhook server. So this webhook server would have some watches for the resources that have references to other resources in their spec. For example, a shoot references a cloud profile and the secret binding and so on. So shoots would definitely be watched. And then on add, update, or delete events, these vertices and edges in this graph here can be maintained. And a vertex would be a really concrete resource. So for example, a shoot in this foo namespace with the name bar. and an edge would be drawn if there is somehow a reference to another resource. So here in this picture again, if we stay with the shoot, there is the cloud profile and the secret binding and config maps. So all these resources that have incoming or have outgoing edges to the shoot can be referenced inside. Yeah, and assuming we have built up this data structure, then the question for such a request that we have seen earlier. So may a gardenlet responsible for a seed called, I don't know, foo, for example, read a particular project. So if this is the request, the gardenlet tries to access a project resource, it would basically mean to check if there is a path here from the project to the seed the gardenlet is responsible for. So by watching the resources and constantly maintaining this data structure, such request can be relatively fast answered. Okay, next step would be to show this graph in a small demo, but I want to first open up for some questions.
Unmuting is enabled, so if someone wants to unmute, it should be possible now. You can also use the chat.
This is Tuyan speaking. I was wondering why is the direction of these arrows? How do you determine the direction of these arrows? I mean, for example, I understand the case of manage seed to shoot and the shoot to seed. This is basically a direct reference from one resource to another, but I do not fully understand, for example, namespace to shoot or secret binding to shoot. Why is the direction to the shoot and not vice versa?
Okay, for example, in the shoot spec, you can reference a secret binding.
Yes.
Right. And you
and
can also reference.
And also a seed.
Okay, so the seed is the only vertex which is a little bit special when it comes to the edges. So let's for now exclude the seed and only look at the others. So again, in the shoot spec, you have the secret binding reference, you have the cloud profile reference, and so on. So this means from all these resources, you get an incoming edge.
But for example, between shoot and manage seed, it's the opposite direction then. I mean, the manage seed references the shoot, not vice versa, but you still get an incoming edge.
Okay, yeah, you're right in this case. Yeah, maybe this is not correct here. So it could be also done that in a different way, that the shoot goes to the managed seed and from there to the seed itself, correct?
I'm not sure. I mean, maybe we can discuss this offline. I was just wondering about the direction.
Yeah.
Okay.
So in the end, the goal is always to have no circles in this graph. So it should always end at the seed. And so this is also the reason why this edge here from the shoot to the seed is different compared to the others here. Because from the spec of a shoot, the cloud profile or the secret binding is not different from the reference compared to the seed reference in the spec. So it's all the same, but still the edges are different. And the reason is, yeah, to prevent these circles here and to always have only a direct path.
Okay, so basically the direction of the arrows is really chosen so that to end up with a acyclic graph, and not so much, they do not so much reflect the real, so to say, dependency. Okay, I got it. Thanks.
Yeah, probably we can also find some very formal rules for drawing these edges. I try to formulate them in the documentation that I have added. Okay, for this managed seed case, I will double check because it also came later. Yeah, that's a good question.
Okay.
I have another question. Is the seed authorizer now also consulted for every user-initiated request? So if, for example, we have the RBAC rules in place that users that belong to a given project can access their shoots and so on. So in case RBAC allows that, is the seed authorizer also consulted then? Yeah,
this depends on, if I go back to this flex here, depends on the order of the authorization mode. So if you first, if you would first have the webhook, for example, then it would be always consulted first. If you would first have the RBAC and RBAC already allows a request, then the webhook would, or all the others would not be consulted anymore. That comes later.
Okay.
So this is more than up to the landscape administrator how to configure it. But,
okay, but the general rule is that the first authorizer allowing a certain request is basically causing the entire request to be allowed for sure and to early exit in this authorization check, basically.
Yes, exactly. Yeah.
Okay, got it. Thanks.
Okay, there are no further questions. Can jump to the demo. Do you see this now, the Safari? Yeah.
Yes.
Okay, so this is now an endpoint in the Gardener admission controller, because the Gardener admission controller component is also the component that has this webhook handlers and also this resource dependency graph. And it offers a configurable endpoint here for debugging purposes that I'm showing now. And this debugging purpose here is to more or less print the graph that it currently has in memory. So you can see here are the resources, the vertexes in the graph. So we have here a backup bucket with this name. This particular backup bucket has an incoming edge from the secret and an outgoing edge to the seed. Yeah, and this is more or less repeated now for all the resources that exist in the garden cluster. If I go down to a more interesting resource, maybe to the shoot that I have. Here I have a shoot in this garden dev namespace with this name. And it has, as just depicted in this diagram, incoming edges from the cloud profile that is part of this shoot spec, the namespace this shoot is inside, the secret binding part of the shoot spec, and the shoot state, and belongs to this GCP seed. That's why it has this outgoing edge. And then again, we can, for example, click on this on the seed. Then we can filter for all the seed resources, and here we can even enter namespace and name. And for the GCP seed, which is the only one that I currently use here in my local environment, you can see there are quite some other resources already in my system that also belong to this GCP seed. So other backup buckets, controller installations, some secrets, and so on. But for example, there are other secrets belonging to the Azure seed, and those don't have any relation to the GCP. And with this now we can restrict the access if somebody with the GCP gardenlet kubeconfig tries to access some Azure or AWS secret or something like this. Okay. This is at the moment all I wanted to show for this graph. Let me go back to the presentation. So the next topic is the gardenlet identity. So somehow we need to know if we get a request, first of all, is this request coming from a gardenlet or from something else? And then the second thing is if it is coming from a gardenlet, which is the seed cluster this gardenlet is responsible for. And the way how this is done, again, inspired by how it's handled in Kubernetes with the nodes and kubelets, is by using this TLS bootstrapping mechanism. So when you first deploy the gardenlet into the seed cluster, then as an operator, you provide it with a bootstrap token. And with this bootstrap token, the gardenlet creates a certificate signing request in the garden cluster and puts its own seed name into the common name of the certificate signing request. And then it is approved and signed by the controller managers. And then the gardenlet gets this client certificate depicted here, where the common name contains the seed cluster name. In this case, the name is AWS. And it also contains this organization, which is then the group of the user, this Gardener Cloud System seeds. And yeah, with this, the gardenlet has its, first of all, own and uniquely identifiable to a seed identity. So when now a request is done by the gardenlet, then this webhook handler can check, first of all, is it a gardenlet by checking here these two fields, and then for which seed is it responsible? In this case, it extracts as AWS. Yeah. This certificate is auto-renewed if 80% of the lifetime is reached. And this is not something new. We have implemented this since quite some time, more or less since the introduction of the gardenlet. But now it already helps us to implement this further seed restriction and authorization handlers. Okay. So the next slide is about speaking about that this is not enough or not good enough to just have this authorization handler, because the gardenlets can still watch list all the shoots and all the seeds of the entire garden cluster. So if I am a AWS gardenlet, for example, I would still be allowed to see shoots related to Azure or GCP. And yeah, this is due to a restriction in this authorization API, more or less, inside Kubernetes, I would say. This is also how it's done in Kubernetes itself. So kubelets, which are only responsible for a particular node, can also see all other pods, even if they are scheduled on other nodes. So there's not much that we can do on our side. At this point, we would need to get in touch with the community and to somehow enhance the API to make it possible to also restrict this read access. But for now, this is how it is. So we cannot prevent that the resources where the gardenlet has a controller for, so shoots obviously, seeds, some other resources, those would still be all visible. So this we cannot restrict at the moment. However, we could restrict which of those resources a particular gardenlet can change or modify. So for example, we would not want that an AWS gardenlet would change GCP shoot or seed in some way. This is something we can implement. However, the problem is that the authorization layer does not have access to the request body. So if you remember the subject access review that I showed earlier, does only contain the user information and more or less the resource name and the verb, but it does not contain the entire object of this resource. So if you want to somehow or need some information out of the request or out of the object body, then we cannot use the authorization webhook. So this means that we also need another webhook in the admission layer. This is also what is done in Kubernetes again. As said, it's quite similar. So there are also two parts, the authorization part and the admission part. And then you can, again, this is now about the last point here on the slide, you can raise the question, okay, would be now only the admission webhook good enough? So can we live with just one? And yeah, the problem is that the admission webhook is not called for the read requests. So for read requests, we need definitely the authorization layer. And for modifying requests, we would need the admission layer. And this is then how this target architecture looks like. Now on the left side, the seed cluster. On the right side, the garden cluster here in this large box. And it depicts the flow when a gardenlet, for example, updates or tries to update the shoot status. So this is a modifying request. It would be sent to the Cube API server of the garden cluster. And then the Cube API server would send the subject access review object to the seed authorizer, to this authorization handler that we talked about, which is part of the admission controller as mentioned. This also has this graph inside, right? It then takes some decision, yes or no. And if yes, then the request is forwarded to the Gardener API server because shoots are managed by the Gardener API server. And then this component would, before it somehow responds or allows the request, also consult the admission handler. The admission handler is called seed restriction and the authorization handler is called seed authorizer. And then again, this separate handler, also part of the admission controller, can check if this gardenlet is allowed to modify this particular shoot status, because only if it is related to its own seed. And if yes or no, then the request is forwarded back to the Cube API server and then to the gardenlet. And this would be then in the future always the flow. So currently, without this security hardening, all the above steps here are skipped. The request is sent to the Cube API server and directly allowed by RBAC because it's bound to cluster admin. But now we would have these two additional checks before indeed allowing the request. All right, so the current state is that we have started to implement the handling of the resources that we have in our Gardener API. Actually, in Kubernetes, it's a little bit easier or less code because they only have 3 or 4 resources that they have to handle. We have some more resources where the gardenlet is acting on. So currently we are, let's say, I don't know, maybe halfway done with this. And for the second half of the resources, we still have to implement the support. So it will take some more weeks, but we are already in a good shape. If you want to check for further information, there's this issue 1723 in the Gardener repository, which contains the explanation again and the current progress. You can also read in the Kubernetes documentation, API access control, the chapter about the node authorization. As I said, we have been heavily inspired here by what Kubernetes has already done. And they, as I said, have this node authorizer and also this node restriction admission plugin that they use both. Also, the identity part is similar. So they also use the TLS bootstrapping with the system node group for the kubelets. So you will see many similarities as mentioned. And then there's also this in the Kubernetes community repository, this design proposal for all of this, which contains a little bit more information than the documentation page itself. If you want to check, you can also have a look here. Okay, yeah, that would be mainly it from my side. Again, opening up for questions or feedback in general.
Hi, Rafael. Thank you. This is Vasu. Thank you for this presentation. I'm just wondering if you go back to your slide with the architecture where the Garden API server is there. I'm wondering, all of the reconciliations are done in the Garden API server anyhow. Why couldn't we just make the admission controller, say, Flapsy, a go routine within the API server? Because then, you would save all these watches and caching and so on, because you could have that cache in the API server anyhow.
Okay, you mean to have a separate webhook a separate HTTP handler in the Gardener API
Yeah,
server
yeah.
next to its normal API.
And you just save, you anyhow build this graph within the API server, and maybe you reuse it also for internal reconciliation purposes. You'd have that. I'm just implementation detail.
I don't have a good answer. I think it could maybe be done, although it might not be, I don't know, let's say convention compliant. So I have not seen that in the past that somebody has extended this existing API with another custom handler. I don't even know if this is supported by this library that we use, by the API server library. Maybe yes. I haven't seen it yet, but I would have this suspicion that it's not supported and only possible with some, I don't know, custom hacks. I don't know.
Yeah, current Gardener API server is heavily based on Kubernetes code, basically, and what Rafael is showing here is easy to achieve by following conventions that are already built in Kubernetes, and what you are asking would be harder to achieve. Probably not impossible, but probably much harder.
Convention and separation of concern. Okay. Yeah, I was just wondering. Yeah.
Yeah, but good point, actually. Yeah. You're right with the argument that the Gardener API server always watches everything and tests this information already. Is actually a good point. Yeah.
Maybe a question from my side about this architecture. Again, you said it will always go through the admission controller in the future. I suppose for debugging and testing, it would still be possible to skip the upper paths.
Yeah, it depends again on what is configured in the Kube API server, because the Kube API server is not part of what we, let's say, release when we release a new Gardener version. So there's only the Helm chart for deploying the Gardener control plane and the gardenlet. But to make all of this here work, you would need to also configure this authorization mode flag on the Kube API server. And yeah, this also means that for local development or development landscapes, you can entirely skip this configuration and simply not activate the upper parts and keep everything as it is today.
Okay. And maybe another question, I understood theoretically why we need also this admission review in addition to the seed. So why we need the admission webhook in addition to the authorization webhook. But could you give a simple example of a request that cannot be properly handled just by the authorization webhook?
For example, create requests where there is not yet an existing vertex in this graph because the resource simply does not yet exist. This cannot be handled by the authorization handler because, yeah, as said, in the graph, there is nothing it could check.
I see.
So for create requests, we might need the request body, the object, to correlate this to a particular seed.
I see. Okay. And with respect to the seed identity, that's maybe the previous slide. There are seeds, or at least gardenlet can be configured to be responsible for multiple seeds. Is this covered?
Okay, yeah. If the garden, so first of all, this configuration for multiple seeds is possible, of course, but more used or more recommended for local or debug development landscape. So for production, it's not recommended. Yeah, it should be done like, yeah, it's done in Kubernetes, 1 gardenlet per seed, as 1 kubelet per node. But if this is the case, then also this would be handled in a way that simply everything is allowed, because we cannot take the decision. We don't know for which of the seeds such gardenlet would be responsible, because this is part of the gardenlet configuration itself and not part of the user identity. So we don't have this information and cannot take any decision.
Okay, so basically, again, testing and debugging is covered, more or less. Everything is allowed. And for production, we don't really care much.
Yes.
Okay, great.
Hi, this is Daniel. I got a similar question to this gardenlet identity. How's it being done in Kubernetes? So a kubelet that has a certificate with a common name for one particular node, I assume it cannot just request via certificate rotation certificate for another node, right? Because otherwise,
forbidden, yeah.
Are we doing the same thing?
You mean for the certificate renewal then?
Yes, that a certain gardenlet cannot just go and request certificate for arbitrary other seeds, similar that a kubelet can request itself certificates for any other node, because as you said, apparently it can actually list those other nodes, the kubelet also, and also the seed.
Yes, yeah, you're right. Good question. So I don't know if we do this already, but we definitely should protect this. Maybe you know better because you back then implemented the renewal yourself. So maybe you know if you have covered this, but if it's not yet covered, then we need to add it definitely, yes.
Yeah, I was just thinking about it. Yeah, okay. I'll check it.
Yeah, nice, good point.